Welcome back. That was our third and final block of talks for the day, and I'm thrilled to be joined by the presenters once again. My name is Joe Gasperetti, joining you from New York, and I've been at Meta since 2013. I'm currently the tech lead for reliability engineering, which is our infrastructure division's reliability program, and that gives me the pleasure of sitting here with these folks today. I certainly enjoyed this last slate of talks. I hope you all did as well. As I was watching it, I was thinking about how each of the talks hit on this topic of how people interact with systems. Reliability isn't just perhaps the architecture we build, but how people interact with it. And so I wanted to start off our roundtable discussion on that topic. And I'll maybe go to Liz first. And I'm curious to hear from you. In your talk, you talked about honeycomb, which is observability is a different way, perhaps, of thinking about monitoring systems from the past. How do you get people to start thinking in observability instead of metrics?
Yeah, I think the way we get people to approach observability and kind of the modern way of looking at all of your signals together instead of kind of disconnected metrics is getting people to realize that when you introduce the idea that you have control over your own telemetry, that you can add all of those things that you previously were logging and just kind of shipping off somewhere that you weren't looking at, and actually looking at the data in the form of trace spans and kind of annotating things. I think that kind of gets people to realize, wait a second, I can deploy something and watch it go live in production, and this is really, really cool. I think the other piece is pressure on cost, that people are starting to understand that no, right, like there's an underlying cost to just shipping all these logs. You just can't do it, keep shipping it and not actually pay for it. So whether it's chargeback mechanisms, whether it be people being under pressure to consolidate tools, there's kind of this movement around, okay, like what's the most efficient and effective way to spend that time and those resources. But yeah, I think it does require some amount of, wait a second, the old way isn't working, like we need to find a better way.
Thanks for that. Speaking of finding a better way, we heard from the meta network engineering folks about the GNTP, and I'm curious, as that was implemented, what kind of cultural or organizational changes were required? Maybe Francisco could take this one.
Yeah, thank you, Joe. So yeah, indeed, there was some cultural change involved into implementing GNTP. I think for the most part was how we deliver the message to the different teams about the safety of operations or the need for safety of operations. I think reliability often gets confused with going slower. And in this case, that wasn't the case. We didn't want to go slow on our network operations. We just wanted to make sure that all the network operations that are performed have guidelines about what we need to check before and after performing the operation, as well as making sure that we are not over touching the network when doing those changes. We wanted to avoid clashes of different changes in the same network scope and so on. So when we went to those discussions with the different teams that maintain the network, there was definitely like some discussions about how we can make these changes without incurring too much speed or changes and so on. I think for the other thing to point out is that as part of our culture, we already had these efforts on reliability, and reliability was also being recognized as part of our performance reviews and so on. So I think that helped greatly into delivering this message. And now I feel like the culture has shifted to once you are defining a new system or building a new system or a new process, you always think into, does this align with the policy that we have? Will my changes be in line with these things that we are agree upon? So I think that that was a major change that we saw in terms of culture.
Thanks for that. I'll go to Joe now at Amazon. You mentioned during your talk, this instinct to revert first and root cause later, and that's the sort of thing that it's easy to say in practice, but in pressure, when push comes to shove, people are dealing with high pressure incidents. I'm wondering how you think about teaching people how to respond to those circumstances, or how to do incident management in general.
Yeah, hi. Yeah, thanks for having me here, Joe. It's a great question because it's something I think about a lot. In general, I think culture, it's one of the most impactful. Having the right culture is one of the most impactful things that we can do for organization. It's also one of the hardest things to scale and kind of to permeate. And I think, I found out it starts with the leaders, right? If you're if your leaders deeply believe in that, and if they repeat that at every opportunity you get, and just like a lot of things in life, just repeating yourself is one of the best ways you can kind of teach folks. It goes a long way. In our case at AWS, for example, we do have a weekly operational meeting where we kind of, many companies do that, but we sit down, we review the incidents of the last week, and primary goal of being just to understand, provide feedback to the teams. But that's also a great opportunity for leaders to be present there and to kind of voice and repeat these messages. And so, just having the leadership all the way from your VPs to your principal engineers, just be there, present, repeat the messages again and again and again, just goes a long way to enforcing the culture. And I think it's hard, but it's when you do it right, it just becomes super impactful for your company.
I definitely see that working in practice. I mean, I joined Meta as an intern a long time ago, and I think one of the things that gave me a good education was attending what we call SEB review, which is our every Friday incident review of the biggest incidents. Just the fact that that was open and you could see engineering leaders talk about, how to focus on fixing and not blaming, how to think about building systems. It was just an incredible opportunity, I think, and I definitely encourage any company that wants to do something like that. Um, Continuing on that culture front, though, we haven't heard from the release engineering folks yet at Meta, so maybe I'll call on Vlad. You talked about tree huggers. Maybe could you describe, are there like specific practices or things that you advise to a team or a company who wants to build an environment where people are like volunteering to do release engineering?
Absolutely. That's a great question. I think that creating a culture where people just want to volunteer to be tree huggers or release engineers, how we call them, this actually requires intentional effort and also an environment that values and supports this. Like based on my personal experience, I think there are several reasons why people do volunteer at Meta and what companies can do to support this. One thing is like, first of all, professional development. So rotation like this provides hands-on experience, in our case with www and web release operations, gives opportunity to learn new skills, which can be like beneficial for personal and also professional growth. Another aspect is that active participation in rotation like this can also contribute to individual engineering excellence and can be like rewarding. Last but maybe not least is like community networking. It's generally fun like to gather with other folks and just to have this volunteer spirit and like contribution to the large organization. So I think this effort should be recognized and valued within the company, and this kind of like gives fulfillment and support and like community spirit. So yeah.
Thanks, Vlad. That's good to hear. Let's take a bit of a hard pivot. We like the warm fuzzies of planning for having a good culture, but sometimes the S hits the fan and things break. So I would like to switch to talking about recoverability a bit. And maybe I'll pivot to Casey since we were on the release engineering topic. Could you talk a little bit about what it's like triaging and resolving break-in code changes?
Sure. Yeah. I think it's important to understand that when we think about our release speed, it's the other benefit of having a quick release speed is being able to make fixes quickly. So when we have issues, we really, as a release engineering team, we don't understand all the codes. We rely on product teams to jump in and help triage, but we have a lot of automation and tooling that helps us find new errors in the system, and that always usually points us in a good direction. And then once we find those issues, we also definitely prefer to just revert. Trying to forward fix things is usually a very bad idea. It's risky, and we can always revert and get that bad change out of the release as quickly as possible. And then when we have more time, we can go back and then do the correct fix. Trying to make a fix under pressure is usually just not a good idea and always has more risk. So then when we actually get those reverts in, the increased speed of the push allows us to make fixes usually within under a couple hours. And if something is very bad, like we have a Sev1, we can always roll back our site, and that takes within a few minutes or 20, 30 minutes max, which is a great final lever to have to make sure that we can get bad issues out of production as quickly as possible.
Thanks, Casey. We haven't heard from Ben yet, and I actually want to call him into this discussion of recoverability as well. Honeycomb is a product built for observing production infrastructure. Obviously, if you build it and believe in it, you're using it to observe your own production infrastructure. So I'm curious, how do you deal with failures in that infrastructure? How do you debug when the debugging tool is down?
Thanks. I love this question because one of my favorite things is, in fact, using Honeycomb to debug Honeycomb while building Honeycomb. So there's a couple of things I want to talk about in relationship to this question. Starting with how do you detect failures when the tool is the thing? I will say when bootstrapping Honeycomb, when first starting it up, we did pull in third-party tools to make sure that everything we were seeing was correct, and we weren't fooling ourselves with some problems we built and didn't see. But as soon as we became able to trust the basics of the product, effectively what we've done is set up 3 copies of Honeycomb. So there's our production infrastructure, and we heard 3 copies in the deploy stack too. This is a bit of a pattern. So there's the production Honeycomb, which feeds all of its telemetry into our second layer Honeycomb, and that's the one we use for production operations to understand when we have reports of issues and so on. We use that heavily to understand what's going on in production. But of course, you're asking about how we find errors within Honeycomb itself. So we deploy to that secondary instance, and all of its telemetry goes to the third one. But there's still a bit of a catch here. If you deploy the wrong thing at the wrong time, things will just go silent. So that third one, in fact, feeds back into the first. We call this observability framework the Ouroboros, as the snake is eating its own tail, which sounds terrifying, right? Because generally, when you get some request coming into your system, the telemetry you produce is more than the volume of that one little request. So you're setting yourself up for an amplifying feedback loop where the production request generates 20, secondary request generates 400 tertiary requests, and then everything just comes crashing down. But the key here is intentional dynamic sampling, trace-aware dynamic sampling, where an interstitial point between these environments is able to look at the telemetry and understand whether a particular event is interesting or not, and forward on more of the interesting ones and suppress the boring ones, so that your high volume traffic, that's all good, right? Most of your traffic is successful and normal and boring. We can drop that traffic effectively, and that suppresses this amplifying feedback loop. But I do want to say, Casey was talking in the www release loop about being able to see your changes as they're going in C1 and C2 before they hit production. And that's actually the majority of our use, is not really looking at things when they've broken, but using the tool in order to facilitate the development and release process. Every aspect of building Honeycomb is tied with being able to see what your code is doing as it flows through these different environments, as it's running in production. And you'll see these graphs show up in PRs. You'll see them show up in demo day when we're presenting the work that we've done, because it's our evidence. And so it's as much of an integrated part of the Honeycomb development process as our source control and everything else. Bringing this idea that seeing your code running in production with everything that comes along with it is a part of the development process is really the thing that makes debugging the failure case easy.
Cool. Very interesting. Thanks for that Ouroboros description there. In the same way that you use Honeycomb to debug Honeycomb, you need the network for basically everything. I guess it's kind of the air we breathe. So I will kick it then to Abhinav on the meta networking side. Can you discuss, how we keep the network health service healthy when it relies on the network?
Oh yeah, sure, Joe. So I think like we try to follow like a two-step thing here. Like the first step is to ensure that the batch change doesn't reach fleet. So over here we have like put on like different kind of hoops through it, right? So the first hoop can be like the fact that we do like on-diff testing, like, and the second thing can be the fact that we do like a lot of A/B thing. So like a same request is sent to dev and prod. If is there some kind of issue, like then we'll block the thing. So in these kind of processes, we do like gradual rollouts. We also have a concept of a shadow tier. So any change which is like being put out, we will send like 1% of shadow traffic to an RC tier. If there's any kind of issue with that, RC tier will block the change. So these are the two steps. This was the first step. The second step is mostly the fact that suppose that the batch change reaches prod, what do we do then? In that case, we actually have like a dashboard alerting rate, like all those kind of monitoring that we have set up from the client side as well as the framework side, which ensures that the framework works well. And like we have also implemented some kind of rate limiting things here as well, which kind of prevents us from like a single client like sending some kind of DDoS attack to us. So there are different mechanisms which we have put in different stages here, which like ensure that the framework remains fine.
Cool. We have a question coming in on the live stream that I want to go to now on recoverability as well. Maybe I'll pass this to Joe first, and then Ben wants to chime in. But the question from the thread is, how do you deal with cross-service consistency expectations when one of the services restored is from a snapshot that is lacking, say, N hours of data?
I like this question because it actually hits on a couple of really interesting themes. The first one is that the stateful systems tend to be some of the hardest systems to recover just because they deal with state. And, maybe the first observation I make based on my experience is that if you are trying to answer that question in the midst of an outage, you probably have already lost. So you kind of want to start early and think. And typically, the term we use here is RPO. You have to think about what's your recovery point objective. And it will vary greatly for many systems. For some systems, you want to be always up to speed. So the answer is you just can't, if you recover to a snapshot, but you don't put the system in service until you've dutifully replayed all the entire change log, and you've caught up to current time, just because otherwise a lot of badness is going to happen. Your clients, your typical bank account example, your clients will make wrong transactions and so on. For other systems, we might have a lot more flexibility, and maybe having a data that is less than an hour old is good enough, and we want to put the system into service really quickly before we fully caught on. But that's a question you want to answer at the design phase, and you actually want to be very explicit to what are you designing to, because starting with unless you test to it, you're just going to have to assume that it's not going to work, and so you want to not only design to that particular recovery point objective, but also test that your clients all behave the way you expect them to, and they can continue working as expected. And then lastly, there's also systems where you kind of wanted to have the opposite. Maybe a lot of systems in observability space, the old state is not that useful, but the current state, the recent events are the most interesting. So you kind of want to do the opposite and not recover from the snapshot, but just get the live data flowing, and then eventually, slowly, you will backfill and you kind of recover old state. And so just all of it goes to, this is some of the questions you want to really ask yourself at design time. And you want to be super explicit, like write down your tenets, write down your expectations, and then test.
I guess, one way of not having to recover is to just stream from the live data, like you were mentioning. And we actually have a question on the thread about that, maybe for Liz. Could you talk about doing analysis on streaming data as well as the snapshotted data?
Can I jump in with one more bit on recoverability here?
Go ahead, Ben.
I love this focus on stateful systems because, first off, yes, they're more difficult to recover from when they have issues, but also they tend to be a little more stable, so you don't get that failure case so often. And especially in a high change environment, it leads some distrust that it's going to work the next time when it's been a while. So one of the techniques that we employ is to make the failure case the normal case, and try and bring in the routine testing of this failure case that you were talking about, Joe, in the regular life of the service. We go so far as to effectively yank the cable on one of our stateful machines every week in all of our stateful fleets, just to be sure that, in fact, there wasn't something that came out this week that influenced that process in some other way. We do this during business hours when people are around to understand what happened in a way that's protected, so that we're not going to wake up in the middle of the night and try and find how to repair this stateful system that has failed to get its state back. So I really appreciate that focus on ensuring that you understand what it's going to do when it does come back, how it's going to behave, and ensure that all your clients understand that by doing it all the time.
Love it.
I love that. It reminds me a bit of so we do what we call storms at Facebook or Meta, where we unplug a whole data center region. There's this funny XKCD about like, oh, don't I throw away a rack? We throw away whole data centers. Um, but anyway, sorry. Let's. I'm curious still about the streaming analysis and as a way to get back online without having to recover snapshots. So I'll bring it back to Liz.
Yeah, these things go hand in hand together, right? Like if you have systems that are built off of streaming, then if you do have to recover from a snapshot, you can always just replay the stream to get caught up. And then I think the other useful technique with working with super fresh data is as you're progressing the stream, you can then look for interesting anomalies or things that are coming in through the stream. So for instance, we've built out features around detecting when you have a failure of your service level objective based off of the incoming data. And when it starts to turn sour, when you start to see that say a client of ours is having 99.9% successes and say they start having 99.4% successes, we can alert on that delta and very rapidly tell them that something's going on. Even if, right, like, Joe, you were saying earlier, like, sorry, Joe, you were, right, like, Joe M, you were saying earlier, right, like, you might not necessarily care about the data that's hours old. Eventually, people do want that data back to understand, what's my SLO for the quarter as opposed to what's my SLO in the past 5 minutes. So kind of having that ability to run that backfill automatically based off of, again, like that same pool of streaming data is an incredibly powerful technique because essentially, right, like what this means is the people who are producing data into your feed don't need to care about how the data is processed afterwards. They don't have to care about persistence other than did the streaming service like Kafka get it? And then everything else from there downstream is a matter of what each of your consumers wants to do and what their kind of checkpointing RPO and replay strategy is.
Thanks for that. Okay, let's get it a little bit into, how we revert. Revert is a big part of recovery as well, and we have some questions here on the thread for that. So I'll go first to Francisco. I have a question here. You describe the rollout procedure for changes to the fleet. Is the rollback procedure the same, or do you do something different for emergency fixes?
So it's using the same tools, definitely, and we also have the ability to do this rollback in different phases, especially when we are in an emergency situation where we have part of the fleet offline or we are having service impact. We need to decide how fast we need to go. So our tools give us the ability to start rollout or rollbacks all at once or start a rollback in a scaled way, which is similar to do when we do the rollout. But the tools and the backend and everything is pretty much the same. It's basically this we can do the same operation for 10,000 devices or do it with only 100 devices that were impacted, and we can go either slow or fast depending on the needs or the urgency of the rollback.
Great. Thanks, Francisco. And thank you to everyone. I have questions for Miles, but I think they're going to pull me off with a vaudeville hook if I keep going. So unfortunately, that is the time that we have for today. Thank you so much to those who dialed into the live stream and for the questions you contributed. And thank you so much to our speakers. 10 to 20 minutes of speaking on a live video is probably 100 times that in preparation, and it really shows in the quality of the content. So thank you so much to everyone who participated today.